Welcome to Mastering Machines, where we discover tomorrow's reality.
Welcome to Mastering Machines, where we discover tomorrow's reality. We hear a lot in the AI community about AI replacing developers and software engineers, or making them, 100x more productive by the tools that AI has been able to create. Well, on the other end of the spectrum, how about AI being used as a scientist? That is part of the title of this paper that just recently came out, that is called The AI Scientist Towards Fully Automated Open-Ended Scientific Discovery. This is such a game changer for not only the AI community, but also the scientific community as well, because what this AI is proposed to do is that it can generate novel ideas, conduct experiments, and write full scientific papers, all without human intervention. This isn't something that, is on the horizon or something that's a couple years out. This is currently happening right now. This was developed by a team of researchers that include Chris Liu, Kong Liu, and Robert Tayarko. The AI Scientist is the first comprehensive framework for fully automatic scientific discovery in the field of machine learning. There was a lot of hubbub about this on Twitter and with the AI community, and some people might not understand or might think that, don't LLMs already do this, or don't they already kind of achieve that? And no, they haven't. So what's the big deal about this paper? Traditionally, the scientific method involved a researcher collecting background knowledge, forming hypotheses, and then designing experiments, collecting data, and communicating findings. This process, while effective, is limited by human capabilities, time constraints, and just everything that comes with human scientific work. However, the AI scientist can perform all of these steps autonomously, potentially accelerating scientific progress at an unprecedented rate. The process for the AI scientist can be broken down into three components. The first one is idea generation. The AI starts with a broad research direction and a simple initial code base or database, and then it uses advanced language models to brainstorm diverse, novel research ideas. And then each idea is scored for interestingness, novelty, and feasibility, and then it's given a score based off of that to the AI scientist. The second portion is experimental iteration. Once an idea is selected, the AI scientist designs and executes experiments. It uses a tool called Aider to implement code changes and can even fix errors and timeout issues automatically. And then the third component is the paper write-up portion. After the experiments are complete, the AI writes a full scientific paper in what's called LaTeX format. LaTeX format is a markup style for scientific papers. Once it's been put into that format, it puts all of the sections that it's experimented on into a comprehensive paper that is on par with human-made papers as well. Also, the scientists that are behind the AI scientists have developed an AI-powered review system based on the Neural Information Processing Systems, also called Neural IPS, conference guidelines. This system can evaluate papers with near human accuracy. In fact, when they tested the AI scientist on 500 papers from the ICLR 2022 conference, the AI reviewer achieved a balanced accuracy of 65% compared to the human baseline of 66%. It even outperformed humans in some of the metrics, such as the F1 score. And the F1 score is a metric that is used in machine learning to measure the precision of AI. One of the most important discoveries of the AI scientist is that this entire review process that it conducted cost only 25 cents to 50 cents per review process that was generated through the AI scientist. The implications of this technology are profound and could really expand and accelerate a lot of the research and scientific research that is done in academia. Let's take a look at a specific example of how the AI scientist was used. In one test run, the AI scientist was tasked with researching diffusion modeling, a hot topic in machine learning, and it proposed a novel idea called adaptive dual scale dennising. This method that was proposed aims to improve diffusion models' ability to capture both global structure and local details in 2D datasets by proposing two branches in the standard denniser network. This is a well-motivated direction for the AI scientists that addresses a key advantage of diffusion models over other generative models like VAEs and GANs. VAEs and GANs are ways for the model to compare dataset samples, and VAEs stand for variational autoencoders, and then GANs stand for generative adversarial networks. The truly remarkable thing about the AI scientist is not only it can come up with this idea, but also designed a complete experimental plan, including code modifications, comparison to the baselines, and even evaluation metrics. Everything that a real scientist would do in that particular situation. In comparison to the review process costs, which were 25 cents to 50 cents per review process, cost for the AI scientists to generate a paper of this magnitude was only around $15. Something like this dramatically democratizes research and how it could be conducted for a lot of different entities. But it's not just about individual papers. The AI scientist can run in an open-ended loop, building on its previous discoveries to improve the next generation of ideas that it has. This mimics the iterative nature of human scientific communities, but at a way faster pace. Of course, this technology isn't without challenges. The researchers note that the AI can sometimes overestimate the novelty or feasibility of its ideas. There are also the important ethical considerations to address as well. Some of the questions that arise that are ethical in nature are about the role of human oversight, the potential for bias in AI-generated research, and then how to ensure the responsible development and use of such a powerful technology. Looking into the future, the potential applications of the AI scientists extend way beyond just the typical machine learning. The researchers suggest it could be applied to almost any discipline, from biology to physics. One of the big things that was talked about a couple months ago was that Jensen Huang, the CEO of NVIDIA, talked a lot about digital biology and how that would be an upcoming field in the next couple of years. And with tools like the AI scientists, that might become a reality. As we stand on the brink of this new era in scientific discovery, one thing is clear. The AI scientist is not just a tool, it's a collaborator and potential to the key of unlocking the next great leap in human knowledge and scientific work. What do you think about the AI scientists? Comment below. What do you think is going to change in certain scientific fields? Will this ramp up medical research and scientific research, and we're kind of on an unprecedented era of great breakthroughs in medicine and science? Let me know in the comments below. Remember, mastering machines, discover tomorrow's reality.